Oh, good grief. So what we talked about last class, I won't completely back up. I don't want to do that to you guys, but it's going to make things a little shorter than I had planned. But I'm sure you guys will live with that. Okay. Hide. So back to my screen. Back to my screen. Okay, so back up again. Actually, let me go single page here. And let's just do a real quick 2-second recap. Recap from last week. If we had a function and we had another function and I wanted to, why am I not getting my stuff here? I wanted to calculate that area between the two functions. I would integrate. I would take the top function minus the bottom function, which sometimes I would be able to simplify that difference and then do the antiderivative. And I would integrate from a certain starting point to a certain ending point. Okay, so that was what last week's lesson was. Let's calculate these areas. Here's an F, here's a G, here's the boundaries, calculate the area. In some problems, the boundaries were created because the functions intersected. Some problems we were given the boundaries, but this was the idea last week, calculating this area through this integration process. Now, I'm just giving names, things that these functions represent. So my f of x, and g of x, my top and my bottom, are these revenue functions. So if I have two revenue functions, the space between them is going to be the additional revenue earned, the revenue gained. So I'm going to end up taking this integral. Now I will go back to dual. Hopefully that's not too horrible. And I'm going to undo that. Still trying to figure out what looks the best. It's hard for me because I can't really see it the way you guys see it. It's always going to look bigger on my screen. But so I'm going to take this function minus this function. So that means, I want to make this a little smaller. Oops. Everything's like ginormous. Okay, quit fooling around. So I'm going to integrate from 15 to 20. And let me grab my notes here because I have them in front of me. So my R1, 7.21 plus 0.26 t plus O2 t squared, t is the year, minus 7.21 plus 0.1 t plus 0.01 t squared dt. I wrote these purposefully so the arithmetic would be a little nice for us. So you notice that we've got some of the things here, but that might make sense. There might be some fixed number that's going to be a part of revenues and then other things that are changing based on the year, right? And so if we continue with this, we're going to integrate from 15 to 20. It's going to be 0.16 t plus 0.01 t squared. Okay. Once we've realized that the process in this problem, the question that asks how much more revenue the new model is going to give me versus the old model from 2015 to 2020. Once I realize what I need to do to make that calculation, that process is a friend. It's an old friend. We set this integral up. That's a little new, but then the simplification, no big deal. The antiderivative process, no big deal. 2 plus 0.01 t cubed for 3 from 15 to 20. We're going to plug in the 20. We're going to plug in the 15. These were, I'm sorry, I didn't clarify these. These were in billions of dollars. And so if we end up calculating this integral, if I plug the 20 in, I get that value, and I plug the 15 in, and I get that value, and I subtract them, I'm pretty sure we're going to get 29.416 repeating. And that's $1 billion more in revenue over the 5 years. Our weakness has always been talking about what the number represents that we get. We can calculate lots of things, but then what does that number really mean? So this is not how much revenue we got. This is how much more revenue we got. So it's the difference that we've increased. It's the amount we've increased in our revenue from going to whatever has us getting revenue according to this model versus whatever practices are having us getting the revenue in this model. Okay? So it's the difference between these two, every difference added up. Okay? So essentially it's a total change. It's how much more revenue. It's going to be the change in revenue we're going to see. Okay? It's not the change over time based on one function. It's the change over time from switching or changing functions, going from one to the other. Okay? So, depending on what our functions represent, this calculation of the difference in the two can take on lots of different meanings. Okay? Additional revenue, additional cost, saved costs, surplus in money, lots of different, just depending on what these functions are measuring, we're going to verbalize this area between them differently. But the common link is the area between the two is the difference over time, okay? Or the additional or surplus of value from one function to the other. And essentially that's all profit is. It's the surplus between revenues and costs. We have a certain amount of revenue, we then have certain costs, and the differential part is your profit. Okay. If we happen to have a time where the costs go above the revenue, then we know that that kind of is the idea of that's negative profit, okay, or money that we're losing. So how we think about this area kind of depends on what the nature is of the two functions. All right. So in that problem, I kind of set everything up for you. Kind of told you this is what we were going to do. If you were presented with your own problem that you had to sort of determine that this would be the procedure, this is how it may look. And this is directly from your textbook. Hopefully you're still looking at things like I think you are. Always a question. Always like, what are they seeing? Yep. Okay. Good. You are seeing what I think you are seeing. Yeah, looking at how big it is though. I might need to be doing that. Okay, so projected fuel cost in millions of dollars for an airline from 2015 to 2025 is given by that particular model. Right? So maybe something has happened, you know, locked in prices, blah, 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 made an agreement. And so the cost, they're going to follow, it's going to follow this model. It's going to have a certain base, and then there's going to be a certain amount of increase in the cost depending on the year. Now, given a change in the engines, we may be able to use our fuel more efficiently. And so our cost then may be able to improve, and we're going to follow this model instead of this model. Okay? If we graph these two, we'll see that this is the model that's above this model. Okay, let me go ahead and go to that. So we can see here's the original fuel model. This is the new fuel model that I've already graphed. So in this case, I'm looking at costs. The space between them is going to be money saved. So if we can switch from this fuel cost model and do something so that we're following this fuel cost model, in this problem, that's the benefit. The benefit is money saved. It's still a difference. You know, what's the difference between the two models, and then what does that difference represent? Since in this case, we're talking about cost models, the difference between them represents money saved. So old cost model, new cost model, and so money saved. Okay. The problem then asks us, how much money will the airline save? Well, it doesn't specify a time frame for the savings. It doesn't specify when we're going to make the change. So I'm going to add that on here. I'd say, let's say we make the change. We made the change in 2020. And so I want to know how much we saved from, how much will we save from this year up to 2025, since that seems to be the sort of the base, the end of the models where maybe things have to be renegotiated, etc. But we have an agreement that's good until 2025. We've changed things on our end. So in the terms of the original agreement, our fuel costs are going to come out to look like this instead of like this. How much money are we going to save in those two, in that range of years? Okay, it's not the same amount every year. So it's not like you say, well, it's 5 years, so if I just figure out, you know, if you plug in a 20 here and a 20 here, that's how much you would save and found their difference. That's how much you would save in 2020. But then that's at one point, not every point. Okay, so we're looking at the overall change. Also, these are continuous functions, so T representing years, there's you know, decimal values that represent different points throughout the year. Okay. Now, you know, are you supposed to know which one of these graphs is on top? Not necessarily. I mean, you can maybe tell if you think about these as lines, and this y-intercept is bigger than y-intercept, but you know, if you're essentially, you just need to look at the graphs, which is why I made them for you. Okay. And so we're going to integrate. Nope, I lied. not from 15. We're going to integrate from 20 to 25. The 568.5 plus 7.15 T model minus the 525.6 plus 6.43 T model. And the DT is just kind of our little like, hey, yeah, it's calculus. Okay. All right, so top function, bottom function, in this case, difference between them is going to be money saved. Now, let me see something for a second. I know I went dark on you there for a second. Give me a second here. The calculator was being wonky on Tuesday, so I didn't get a chance to do this. So let me see if it'll cooperate with me right now. I'm sharing that application. I'm gonna close that up. I'm gonna figure out what I'm doing. Let's see if I can. Nope. Oh, no. Okay. Yeah. For some reason, I apologize. For some reason, my emulator is not working. I was going to show you. Oh, okay. Of course, I just said it's not working, and it started working because it wants to make me a liar. Hey, and I have the functions in there. All right. Woo woo. Okay, so let's see if I can share that. Who's the coolest? That would be me. Yeah, you guys are like, yeah, right. All right, so look. There's the cost function, and there's the other cost function. And here's the graph. And let's see, let's make sure, what do I have? Oh, I don't have the window that we're actually looking at. So let's go 15 to 25. All right. Okay. And not sure where I lost. Let me see, zoom. What if I zoom 0? What's happening? Why does it hate me? There we go. Okay. So this is actually the window we're looking at. Oh, we weren't going to do 15. So it was starting from 15 going to 25. We're looking at the part from 20 to 25. So if we trace along here, so there's the 20. So from 20 to 25, what would that area be? And since these are lines, that's actually just a quadrilateral that we could calculate the area of, but so much more fun to do it using calculus. Okay, here's what I wanted to show you. Here comes the money shot. You're like, what's that? Well, let me show you. Some of you have already determined this. You've already talked to your AB friends, and you know that if you have an updated calculator and you do Math 9 gives you integration. Okay. So if I'm going to integrate from 20 to 25, oops, that's cool. Now I could type both of those functions right there. You know, these guys and these guys, this one and this one. But look, This one's Y1. This one's Y2. Y1 was on top. My vars key and yvars gives me those guys. So I can say, hello, I would like the Y1 function minus vars, yvars. And if you're like, where is this? I'm recording this, so you will be able to look back at it later. And they are written in terms of X. So I use that thing. And it does the work for us. It doesn't actually do an antiderivative. It uses a Riemann sum process. Another way you can do that is if you're on here and you calculate number 7, you just have to tell it to go from 20 to 25, and it'll calculate it. Oh, no, it doesn't do the 2. See, that's the area under F. That's from the top function all the way down. Okay, yeah. See, it's not as easy to do. So if we do, I guess you'd have to change functions. Okay, so here's the second function from 20 to 25. It's okay. I can't do. All right, so this part's not going to work very well because it only does area under 1. It goes from 1 down. I'm sure there's a way to get it to just do this part with some kind of subtraction. I don't have that knowledge, but right here is exactly what we would do. Just let the calculator do all the heavy lifting for us. Hold on. I wish there was an easier way. There probably is an easier way to switch back and forth. I just don't know what it is. It's not that it doesn't exist. It's just I don't have it. But, what we would do without any of the benefit, I just have this art, but I already have it worked out. So 42.9 is your constant plus 0.72 t. They're outside mowing again, like they always are on Thursday mornings. So this is 42.9 t plus 0.72 t squared divided by 2 from 20 to 25. And if you crunch that out, I'm fairly sure you're going to get the 295.5 that the calculator gave us. So the magic buttons on the calculator, Math 9. Okay. If you have an updated operating system, if you have an older calculator, it will do it. It's just not going to look like this, and you have to know a little bit more about how to type stuff in. The functions, you can type the full functions in these places, but if you already have graphed the functions and they have names attached to them, like y1, y2, y whatever, then when you, sorry about that, guys. It's not going to work now, but when you do that, then you can use the vars key and it goes over to yvars, and those are when we have in terms of what functions in terms of y. So, what am I going to ask you to do? That's always the bottom line. So your final assignment is actually going to be a lab. Okay, it's going to be an application lab. All right, let's do this. Oh my goodness, I'm switching again. Go figure. She's a nut. She's switching again. She's going to show us something else. Here we go. Share. Hide. Okay. Let's see what that looks like. Okay, we got to make it bigger. Bigger. All right, so this is what you're going to have to do. This lab, the title is like calculation of surplus. Okay? Surplus is that area, that space between two functions. What's the difference between one function versus another? Now, in this case, these functions are going to be generated by you using regression, and they're going to be functions that represent two aspects of the Social Security Trust Fund. Right? The Old Age and Survivors Insurance Trust Fund is its original name. So this is representing, starting in 1990, money collected in Social Security from people, involuntarily taken out of your paycheck. So total money collected, receipts, and total money spent out, paid out in Social Security. And what we would be hoping, obviously, is that whatever money we're taking in, the money we're paying out is less than that, so that there's some kind of difference, some kind of buffer, surplus, okay, over time. So what we have is data starting from 1990, going up to 2009. Based on this 20-year data, I would like you to use your calculator or use Desmos, come up with linear regression models, create a graph, calculate the area between the two models to calculate the amount of surplus money available. That's if a linear model makes sense. And then I'm going to ask you to repeat that process, but using quadratic models. Okay? If you need any help using your calculator or using Desmos to do that, that's definitely something you can reach out. You can email me. You can come see me in office hours, and we'll pull Desmos up, and I'll remind you about how to do the regression. You're going to have to type the tables of data in, but we can do that. So, and then you're going to calculate the area. And then here's the thinking part. You're going to talk about, what would it mean if they intersected? What would it mean? Think about if these intersect, what does that mean if receipts goes under expenditures? What does that mean? And then, you're going to just do a little reading and talking. So you're going to go to this link, which is from the Social Security Administration. You're going to scroll through until you get to what's labeled as Chart 2, panels A through F. You'll see 6 different graphs, and they're graphs of revenue and expenditures. And I want you to look at those graphs and the scale on the graphs, what you see on the graphs, and tell me what you think they're saying. And then I want you to read 2 short articles about Social Security and list one fact from each article that you found interesting. So no wrong answers on number 7, because what did you think was interesting that it was in there? As long as you read the article and are talking about something that's in there, you can't possibly be wrong. Okay? So that, my friends, is your final assignment for applied calculus, if you choose to accept it. If you've not done any of the other assignments, or you're still wanting to do the assignments, obviously they're still available on Blackboard. Clock is definitely ticking, because there is going to be a point where I'm going to be like, nope, gotta have your grades turned in. So make some decisions about what you want to do with that. If you've already done some and you want to wrap things up, well, great. If you haven't done any but you want to do some redemption, I'm not outside of that being a possibility. So let me know. That's going to be it. So last assignment, I will be available in office hours tomorrow from 11:30 to 1. Yeah, today's Thursday. So Friday, tomorrow, 11:30 to 1, I'll be in office hours. Next Wednesday from 11:30 to 1. So you got 2 opportunities in office hours. We're going to make this assignment due, I don't know what it says on my handout. So let's go back to that for one more second before we finish. Okay. Yeah. So you guys were kind of, just erase that. So you're going to be due by 6 on Thursday, a week from today, which is the 28th. Okay. So Friday, 11:30 to 1, and then Wednesday again from 11:30 to 1 are office hours. I will be here for class Thursday morning. If you need to pop in and ask me anything about any assignments or whatever, I'll be available, or you can just pop in to throw an emoji up and say goodbye, because that's going to be our last official meeting. We will not do a lesson. It'll just be sort of wrapping up last things. So that's all I've got for today. Let me know if there's anything I can do for you to facilitate wrapping things up. I'm not going to say goodbye today because I'm going to say goodbye next Thursday, but if you want to say goodbye today, you can. I hope you have a great rest of the week. I'm looking forward to celebrating with you guys through some senior opportunities. Hopefully I'll see you turning stuff in, or see you during the awards assembly or other things that are going on. And eventually, hopefully, we'll get to have a graduation together. Okay? You guys have a good rest of the day. Have a good weekend. Happy Memorial Day. Let me know if you need something. Otherwise, that's me plus my gang. Bye, Neha. You guys have a good day. You're welcome. Goodbye. Yes. Peace out. You are welcome. You're welcome. You're welcome. You're welcome. Bye-bye. Bye-bye.